In this video we're going to talk about a thing called broadcasting that we can do with NumPy arrays. As with almost everything, in this course we're going to need to use NumPy, so we're going to do our first line of our file, we're just going to import it. Okay, so now explain what broadcasting is about. Well, let's just start by defining a couple of matrices. So let's say 11, 22, 33, 44 as our first matrix, and B is going to be 1, 10, 100, 1,000. Okay, so here's our two matrices. Now, if you remember, we could multiply these matrices using the usual rule for matrix multiplication. Remember, that's with an @ sign. Okay, and if we do, so that's the usual product of this matrix and this matrix. You know, the 11 times 1 plus 22 times 100 gives you this 22, 1, 1 here, and so on. We could also just do star, right? So you know, it's kind of a mistake if you want to, if you wanted to do matrix multiplication, you wrote a star, that would be wrong. The star is just the kind of more obvious sort of thing, more obvious kind of product where you just multiply individual entries in the first matrix by individual matrix and entries in the second one. So here you've got the 11 times the 1 gives you a 1, the 22 times the 10 gives you 220, 33 times 100 gives you 3300 there. 44 times this 1,000 gives you this 44,000. Okay, so that's what star means. And if we did a matrix of a kind of different, completely different shape, like okay, so now if I try and do A star U, you know, this is these things have just completely different shape. You can't match up the entries in A with the entries in U, and so we just get an error. But we could try doing something a bit different. So we could do well, the most obvious thing we could do is we could just do A times 100, say. Yeah, so we get this thing here, but there's already something kind of maybe non-trivial going on here. When we do the 100, you know, so this is the same thing as kind of multiplying every entry in A by 100. So what you've done is essentially you've taken this 100, which is just a number, and you've kind of converted it into a 4x4 matrix where there's 100 in every slot, and then you multiply things together in pairs. And and now here's another thing, actually. So actually, maybe let's have a name for this. Okay, so let's call this one V. Okay, so so here's our V and here's our A. So here's our A was this matrix like this, and our V is a vector like so. So these have different shapes. You know, V is kind of a 1x2 thing, and A is a 2x2 thing. But we can still do multiplication together, and you see what it's done is multiplied everything in the first column by the 100 and everything in the second column by the 1,000. That's what we get. And remember, as usual, this is kind of different from the sort of matrix times vector product that we see in linear algebra. This is just kind of the pointwise thing, but you see what Python's essentially done is to take this row and then just kind of make two copies of it. So we multiply the first row here by this thing, and then the second row here by that thing. And actually, let's print the shapes of these things. So A is a shape 2 by 2, and V is a shape 2 by just 2. There's no thing. So what Python has done is to kind of implicitly it's expanded the V, made two copies of it to make it into a 2 by 2 thing, and then multiplied. And that's what's called broadcasting. You've kind of broadcasted you started with a row vector and you made multiple copies of it vertically. That's called broadcasting. Yeah, and so what happens actually if we wanted to do it the other way around? If we wanted to multiply the first row by 100 and the second row by 10,000. So what we could do there is we could so now I've made V be a column vector. Okay, so it's a column vector of shape 2 by 1. So what Python does in this case is to sort of kind of broadcast it because it's a column vector. The obvious way to kind of copy it to sort of make it match the shape of A is to sort of have two columns, each equals 100 and 1,000. And when you do that multiplication here, you get this business like so. And here's another example. So let's so let's make a row vector. And let's now we want to make a column vector. Okay, well let's make a row again, another row vector first. So here we go. Here's Q. That's a row vector. We can turn it into a column vector by transposing it, and the Python notation or the NumPy notation for doing a transpose is just to put a .t on the end. All right, no, we've done this wrong. We have to okay, so I have to so for this transposing thing to work, I have to make my original Q be not exactly a vector, but a matrix, a row matrix. So I have to put an extra pair of brackets. So if I didn't have the brackets, then okay, let's actually maybe do this again. So if let's do Q naught is the thing with only one pair of brackets, and Q1 is thing with two pairs of brackets. So so we do Q naught dot shape. So shape of Q is just Q naught is just 3. If I do ndim, Q naught is the number of dimensions is just 1. There's only one index here. It just kind of goes from 0 to 2, and the shape as we saw a minute ago is just 3. If we do whereas we do Q1. That's kind of officially got 2 dimensions. It's a two-dimensional thing like a matrix, except that there's only one row. And if we do the shape, okay, so that's 1, 3, so 1 down and 3 across. That's the shape of your Q1. So to Q0, I mean, if I wanted to I do Q0.reshape13, that'll put it in the same form as Q1. Okay, but anyway, so then and we can transpose Q1, and that makes it into a column vector, or actually another equivalent way of doing the same thing. I do Q0.reshape31, so that either of those things will will give me a column vector. So now, yeah, we've got our P and our Q1, say. Yeah, so actually, let's change Q1 to just be equal to the transpose, like so. So, okay, so now. So here's our P, it's a row vector. Here's our Q1, which is a column vector. And okay, so so now we're going to do P times Q1. Okay, and that it turns out that this gives us a 3×7 matrix. So what's going on here? You know, we want to try and multiply the elements of P by the elements of Q, but they don't have the right shape. But we can kind of make them the right shape by if we just kind of duplicate P by taking 3 copies of it stacked vertically, and we can duplicate Q by taking 7 copies of it stacked horizontally, and then when we multiply those two things together, what we get is this result here. And so that's again what's called broadcasting. Trying to multiply two things which have different shapes, and Python will try to do some. You could look up the precise rules if you want, but broadly speaking, it just tries to do the most obvious and most sensible thing to make two things of the same shape by copying and then multiply them. So yeah, so that's the basic idea of broadcasting. And but I'll also mention that we can let's maybe go back to the previous example here. Yeah. Let's go back to this A and B here. So you, of course, you can we just do the sum of A and B. You just take the you just add together the corresponding entries in the usual way, and we can also do something like np.max AB. So we can take the maximum of A and B. No, that's actually it's not going to quite work as you need to. Yeah, actually, let's just ignore that example. There's a bit more of a story there that we'll discuss later. Okay, but yeah, so we can add or subtract, and then here, yeah, I mean again, if we just go back to this example here, we did multiplication, but we could try and do addition, and again it does the same kind of broadcasting. You get 3. You take. So maybe we could try. Yeah. So if we wanted to try and make a bit more explicit what's going on here, we could do. So we want to do. Okay, we want to be broadcasting Q column. So yeah, this we want to be Q1 here. Could do something slicker rather than just but yeah, so here's yeah, so this was the effect of broadcasting Q1 here, and so so in this broadcasting process, this P, you get 3 copies of P vertically stacked, and the Q1, which started off being this column vector here, you get 7 copies of Q1 horizontally stacked, and then these two things have the same shape, and then and then if we add together the kind of broadcast version of P and the broadcast version of Q, then we just get this thing here. But actually we didn't need to do all this broadcasting explicitly. Python kind of does it in the background and gives us this same answer here.